My name is Andy James, and I'm a Senior Solution Engineer at HashiCorp. Today I want to talk to you guys about how Nomad works. I want to talk about sort of the orchestration engine. I want to talk about the developer experience. I want to talk about bin packing, and I really want to talk about sort of the overhead and the operational costs of running a product like Nomad. When we talk about Nomad, Nomad is an orchestrator. So what people like to ask us is, what is an orchestrator? So think about a musician's, think about an orchestra. Think about, you've got the conductor at the front, he's got a baton in his hand, he's waving it to give directions to all the musicians. The musicians are staring at music and following off the music, but at the end of the day, to know the timing, to make sure that they don't miss a beat, to make sure that they're holding the right amount of time, they depend on the conductor to really make sure that they know when their time is and when to actually play their instrument. So in the IT world, an orchestrator does just about the same thing. The idea here is we've got all of these different jobs, and these jobs can be containers, they could be raw executables, they might be jar files, whatever it may be. You have these things that you're trying to run across all of your infrastructure, and you need a way to tell it when to run, where to run, and how to do this efficiently. In sort of older way of doing things, what we would do is just run Docker on all our systems. We would build our containers. We would just sort of let them run forever, and this is how we did things. But now that orchestrators exist, we're able to really efficiently use our infrastructure that's available and make sure that our jobs are placed in places that make sense. So think about data analytics. This is where sort of orchestrators became a really big thing. The idea with data analytics is that we've got large amounts of data, pools and pools of data that fill up terabytes and terabytes and petabytes of storage, and I can't use a single job to process all that data. I could run a single job, but then I'd have to wait many, many years for it. So the whole idea here is that now I can give an orchestrator that job. It can efficiently use all of the resources available in my infrastructure and process that job much quicker. And here's the thing, these jobs don't have to be complicated. They don't have to be complex. This could be as simple as a PHP application running your website, or as complicated as these big data query jobs. So it's all about how can we be efficient managing the tasks, and that's the goal of an orchestrator. How does it do that? That's a great question. That's all done with a concept called bin packing. So if you actually Google bin packing, it's just a mathematical equation. It's all about how do we use our resources efficiently. So I'm going to step off to the side here, and we're going to look at these pretty drawings I did. So the old way of looking at servers is that we've got all these jobs, and we use the same colors to sort of show the same job running across multiple servers. So imagine these are all 4 servers. They've got different jobs running. We've got 3 different jobs across all of these servers. But if you'll notice, there's all these sort of open spots. These spots are open because we're not utilizing our infrastructure to the most of its efficiency. So then what we do with bin packing is this sort of fits under the new model. So with something like Nomad, we've built this. And what happens is that Nomad can then efficiently determine where we should be putting each of the jobs. It knows there's enough space to run these 3 here, so it puts them on this server, and this server, and this server. And what you'll find is because I had all of this open space, I was actually able to completely eliminate the need for one of my servers. So this is the luxury of bin packing, is that now I'm using my resources a lot more efficiently. So the second half of the bin packing sort of mathematical equation that Nomad does is called anti-affinity. With anti-affinity, which is missing from this drawing, I'm also able to determine if the same job is running on the same server. This is very important when you start thinking about redundancy, HA, replication, and DR. I really can't have all my jobs on the same server, even if the resources are available, because if something was to go wrong, I lose that server, and in losing that server, I lose all my jobs instead of just one of them. So the idea here is with anti-affinity plus bin packing, we're able to look at your resources, we're able to look across your infrastructure and make the right decisions for where each and every job should be running. By doing so, what we're really tying into is efficiency, and efficiency is money saved. When you think about sort of the old adage, a penny saved is a penny earned, this is true when you think about your cloud infrastructure, your on-prem infrastructure, anything you've done hybrid. It doesn't matter if you're an open source, small little company or a giant enterprise. if you can cut down on how you're using your resources and make sure you're using them to the most as efficiently as possible, you're able to take those resources and cut down sort of the overall amount required. So this is what we're really going after. The other thing that all of this does is because now I have a tool to talk to called the Orchestrator or Nomad. Now that I have this tool to talk to, I can lower my dev time and my dev deployment times also. They're not having to learn how to talk to the servers directly. They're not having to learn how to deploy to all of this infrastructure. All they do is talk to the Nomad API. So let's talk about what Nomad can run. Well, Nomad can run anything. Our tagline is deploy and manage any application on any infrastructure. And the whole idea here is it doesn't matter if it's a single cloud, multi-cloud, hybrid, on-prem, it could be a Raspberry Pi. We can run Nomad on any infrastructure you want to run it on. The Nomad is written in Golang, which means it runs on any OS too. You can run it on Windows, you can run it on Linux, you can run it on ARM. It doesn't matter. Nomad is happy to run. By doing this, we're now able to run our applications on any infrastructure and on any OS. The second half of that is that we can run anything too. We support isolated and raw executables. We support Java, so you can run your jar files. We support your Docker containers, just like you think of. And all of our task drivers are open source. Where this is very important is that even though Nomad has this open source product and an enterprise product, the task drivers will always be part of open source. This means that as the community, we can work together to build more task drivers and make Nomad even more extensible than it already is. Now that we've sort of talked about what Nomad can run, how it can be run, what OSs can it be run on, what hardware you can run it on, and you've sort of seen that really Nomad is completely extensible and flexible so that we can give you whatever you need. Let's talk about actually building a Nomad cluster. Because it's great that it can do all these things, but if it's really complicated to actually do this, what's the value? So the reference architecture for Nomad is 3 or 5 Nomad servers. That's it. So a cluster for us is 3 or 5, and then you run the Nomad agent on any hardware that you want to be able to run a Nomad job. And as I said earlier, Nomad jobs can be anything. They can be bash scripts, they can be really complicated, data analytics jobs, they could be just your PHP website running in a container. It doesn't matter, but anywhere you run the agent, this is where your jobs are gonna run. So what happens here is that now that you've built out these 3 servers, these jobs, you're probably wondering, okay, well, how much work is it to manage all of this infrastructure? Well, it's really not. Nomad is a single binary, even for the agent side. It's the same binary for both, and it's a simple config file. It's very straightforward, and with something like Terraform, you can actually automate your entire deployment of all of your Nomad infrastructure. The one thing that you do usually add to your Nomad deployments is our console product. Built right into Nomad is support for Console Connect, which means that you can get a service discovery and service mesh deployment out of the box with Nomad. It's as easy as deploying the console agent when you're deploying Nomad onto all of your servers. Really straightforward. The other thing that's built right out of the box into Nomad is the Vault API. So if you need access to dynamic credentials, you want to store your secrets, you really want to improve the security of all of your sort of application to application communication, this can all be done with Vault, again, right out of the box. So if you're a company already running Vault, already running console in your infrastructure, adding in Nomad and then taking advantage of all of this sort of additional security and networking resources is very straightforward. Single binary. We've talked to customers that are running sort of the Nomad infrastructure, and they will have thousands of developers, and one of our larger customers has over 11,000 Nomad nodes. On those 11,000 Nomad nodes and those thousands of developers, a team of 4 SREs manage the entire infrastructure. So it just gives you the flexibility and power that Nomad provides to your company. So the very last thing I want to talk about is, so we've got infrastructure, we've talked about how all the infrastructure is deployed, we've talked about how easy it is to make it. So let's talk about your development experience. So the very last thing in concept in Nomad is called a job. A job is anything that we need to run. So the development experience is all about how easy is this to do? How much do I have to learn? Talking to our customers that have done this, the average onboarding time for a developer is about 30 minutes. It's as easy as learning the HashiCorp config language, which was designed to be simple, so anyone can learn it. And the model for us is as simple as a job, a group, and a task. The job is the overarching wrapper. The group is the section of things, so databases or web servers or whatever it may be, and the task is each thing you have to run. So I need web servers 1 through 3, I need databases 1 and 2. It's designed to be simple. So your developers are writing one file for their application, and it will deploy everything they need. This is different than a lot of other orchestrators on the market that have multiple files for each application. Ours is a single file, a jobs file. And what's even nicer is that when you start pipelining this and you tie this into your CI/CD infrastructure, it's as easy as using Terraform to create and deploy those job files. So this can be made incredibly easy. So we've talked about Nomad across this entire talk. It's an orchestration tool. It does bin packing using a bin packing algorithm. It has a simple job syntax that anyone can learn. It's all written in HCL. It supports console and vault out of the box. And because Terraform also provides a provider for Nomad, it's easy to use with Terraform. It's a single binary that can be deployed on any operating system, on any cloud, in any data center, and it'll even run on a Raspberry Pi. And that's a little bit of an overview of what Nomad is. To learn more about Nomad, I recommend visiting learn.hashicorp.com and checking out the Nomad track to learn sort of how to use Nomad, what operational tasks you can do, and how to build jobs. If you want to learn more about sort of case studies and things that we've seen from the industry, I recommend visiting hashicorp.com/resources or checking out our YouTube page.